So let us now solve our first problem based on the concept of similarity. And this problem came in the year 2003. Let's apply whatever we have learned to solve this problem. So in the diagram given below, ABD, CDB and PQD, all these three are equal to 90 degree. Okay, so what do I understand? This angle is equals to this angle is equals to this angle. All these three angles are equal to 90 degree. So I can see many right angle triangles here. Okay, and triangle inside a triangle, you can understand they have to be a similar triangle. Okay, because they will be having two angles as same. Okay, I'll prove this. Let's see this now. If AB is to CD is equals to 3 is to 1, then the ratio of CD is to PQ is equals to what? So then I understand that I cannot solve this problem by any other way because the ratio of the sides is given and the ratio of the side is being asked. So it has to be solved by similarity. So let's see now. I will have to just understand now which triangles I'll prove to be as similar. Okay, so as to reach on to the answer. That you have to see what is being given in the question and what is being asked. That will help you to identify and prove which triangles will you prove them to be as similar. So let's understand this. AB is to CD is 3 is to 1. Okay, so what you can say? Can you say value from this? No, the ratio is 3 is to 1. So if I multiply this by 2, this becomes 6 is to 2. If I multiply this by 9, this becomes 9 is to 3 and then so on. So I'll say to get the value from the ratio, since I don't know the value, what will I say here? I'll say that just multiply this by x. So this will become what? This will become 3x and this will become what? This will become x. So what do I understand from this? This is the ratio of AB is to CD. So AB is to CD is 3x is to x. So AB is what now? AB is this. So this becomes your 3x, the length of AB. And CD, okay, the length of this becomes equal to x. That's what I start from the problem. Now what am I being asked? I'm being asked what is the ratio of CD is to PQ. So I'm being asked what is the ratio of CD, which means this part, is to PQ, which is this part. Okay, I'm supposed to know this red part. I'm given the blue part. So let's now start thinking about it. Okay, what do we know and what are we supposed to find it out? So as I see first the blue part, okay, I need to understand what will I get from this. So what do you understand from this? I'll know that these two triangles are similar. See this one, ABD. Just see the 90 degree angle. Two angles you have to prove to be as equal. So ABD has to be equal to CDB. Right? These two angles have to be equal. So how will you prove that? But okay, one of the way it is, you can see the 90 degree angle, but then still you will not be able to find the answer. Okay, if you get that, you will get the ratio of the side as AD, then CB. What will you do with that? Okay, you will be getting ABs to CD, but eventually you will not reach on to the answer. Okay, so that's not the way to look at this. So let's understand some other way. So this is an AB and this is CD. They both are parallel. How do I know that? Because this is also 90, this is also 90, so both the lines are parallel. Now I know something about parallel lines. If I form a Z like this, there's a parallel line, there's a parallel line. Okay, these two lines are parallel to each other. If I just connect them by this way, what can I say? The Z is being formed, which means this angle has to be equal to this angle. Why they are equal? Pair of alternate angles. So apply the same logic here. Can you see this Z? This is a Z that is being formed here, right? Okay, so by that logic, I can say that there is a Z that is being formed here. So this angle has to be equal to this angle. At the same time, I can say the Z is also being formed here. Check it in this way. Okay, the Z is also being formed here. Okay, so what do you say from this? I say that this angle will be equal to this angle. So automatically the third angles will become equal, right? This angle will be equal to this angle. Vertically opposite angles. One more way to look at this, which means I've just proved that these two triangles are equal, which is APB and CPD. That's what I'm doing it. Okay, what will I get from that? I have an AB is to CD there. So I will possibly get the ratio of this, which is CP is to PB. What will I do with that? Why do I need that ratio? Because eventually I need CD is to PQ. For that, I'll need this triangle PQB. You understand? PQB and CDB. It's only when I this take these two triangles, I'll get the ratio of their side, which is PQ is to CD. And these two triangles will be similar. How do you know that? Because one of the angle is 90. Just prove two angles are equal. So one of the angle is 90. Angle D is equals to angle Q. In PQB, this angle PQB is equals to angle CDB. Both are 90. At the same time, this angle, okay, which if I just put it here in green, this angle will be equal. Why? Because it's in common angle. It's the same angle, one and the same. CBD is equals to PBQ. It's one and the same angle, right? Okay, so it has to be the same. So I proved that for the triangle PQB and triangle CDB, two angles are equal. If two angles are equal, which means these two are similar. If these two are similar, I can get the ratio of CD is to PQ. But for that, to get to the answer of this, I need the ratio of PB is to PC. If I get that, I'll reach on to my answer. That's how simple it is. That's why I'm using the similarity for these two triangles, which is one APB and CPD. Okay, so what do you understand from this? Now there is one more thing that you need to prove about similarity. We know already everything, but just a way to write this thing. Now you will ask me that we had proved that the two triangles are similar, which means this triangle is similar to this triangle. So we know that this is 30. So this is 30. This is say 25. So this becomes 25. Sum of the measure is now what now? 55, 60, 70, 80. So this becomes 125. So this black are equal. Okay, just for your understanding, I write it in this way, not drawn onto the scale, as you can see it. So these two triangles are similar. So how will you write the ratio of their side? Okay, there is a lot of confusion in that. What side upon what side? What side got magnified to what side? How will I know that? Okay, that is very simple thing. Just see the side opposite to 30 here. So if I say this is triangle ABC, and if I say this is triangle PQR, all that you have to see here is side opposite to 30 is what? CB. So you can write here BC upon side opposite to 30 is what? RQ. So you know that opposite to 30 got magnified in the same way. Okay, the magnification number or the ratio has to be same. Right? So you will write here BC upon QR like this, side opposite to 30 in short, in this way. Then C will be equal to side opposite to 25 is what? Here it is AB. So I'll write here AB. Side opposite to 25 is what now here? That is PQ. So AB upon PQ. Then see what is the side opposite to 125. Side opposite to 125 is AC. And side opposite to 125 here is PR. So they will be having a common magnification ratio. That you will write it here, whatever it is. But this is how you write the ratio of their side. So if I were to put it simple, if three angles are equal, then you have to just see the side opposite to that particular angle in one triangle. Then take the same angle in the other triangle and see the side opposite to that. So 30 के opposite what side? So next triangle में 30 के opposite what side? इस angle में 25 के opposite what side? So उस angle में again 25 के opposite what side you are? Right? That's how you have to check it. So that's how simple it is to write the ratio of their sides. Okay, so you will never make a mistake now. Just see it in this way. So got this as well. So first of all, I know what these two triangles are similar. So what can you write here? Side opposite to this two. Okay, which is you can say. So first I am taking APB. So let's write it here, which will be 3x upon side opposite to this, which is what? X. That will be equal. Okay, as I had already proved that these two triangles are similar, as three angles are equal. The side opposite to this angle is equal divided by side opposite to this angle. The ratio of them would be same because this side got magnified to this. Okay, as you can see, the magnification is 3 times. So every side must have got magnified 3 times. That's how simple it is. So that is equal to this. And what else do you need? See, I need this. I need PB is to PC. So just take this side opposite to this black angle. Okay, that will be equal to what? That will be equal to PB. And side opposite to this black angle is what? PC. So that is equals to PB upon PC. Which means I get the ratio of PBs to PC then. Okay, which is what? 3 is to 1. Which means, as we know it, every side got magnified 3 times. Okay, so PB will be equal to what now? PB is 3 times your PC. So let's write it here. Let's keep everything else as same. So if I put this in yellow, this becomes equal to 3. I'll say 3y. Okay, see, the ratio is 3 is to 1. But from that, you cannot see the value. But for us to solve the value, you need some variable as you did it x here. So multiply this by y. So this becomes 3y and this becomes equal to y. So this is 3y and this is equal to y. Okay, that's what I know till now. So everything looks good till now. Okay, what else am I supposed to know now? Now just find out your answer. You're done with it. You are knowing everything now. So what do you need to know now? In triangle CDB and triangle PQD, these two triangles, you had already proved them to be similar, right? How? This angle is 90 and this green is a common angle. So take it in that way. So this green is the same. At the same time, third angle will also become equal, right? So let me put 3 circles here like this for this. So this has to be equal to this. Okay, that is again quite understandable because the two angles have become equal. So third has to be equal. Now take the ratio of their side with whatever you need it, whatever you need to solve, take the ratio in that way. So what do I need? First, I need this. Okay, I need to find out this only, right? So side opposite to green. So let's start with this. What are they asking? CD. So let's take the bigger one, CD, which is equal to X. Okay, then what? CD upon PQ. PQ is something that you are supposed to find it out. So let's keep it as PQ. Let's write it at CD only, okay, because they are asking you CD. So CD upon PQ, something that I'm supposed to find out. Side opposite to green. In a bigger triangle, it is CD. In a smaller triangle, it is PQ. Okay, in case you're not able to visualize, see, let me just color them because there are so many things written here. There is a chance that you might get confused. So we know everything. We need to find out CD upon PQ. So eventually, I'm looking at this two triangles now, which is one of them is this yellow one, this one. Okay, this yellow one, I'm comparing this with, let's say, this green one. This green and the yellow. Okay, if you see this is how it becomes complete. This green one is being compared with this yellow one. These two triangles are similar. Okay, and how do you know that? This is 90. This is 90. Two angles are equal. At the same time, there is a common angle. So this is equal to this. Because in yellow and green, okay, both you have this angle. So if I complete this green, as you understand, this is a common angle in both the triangles. Okay, so it has to be same. That is one thing. Okay, and then finally you can say this has to become equal to this in yellow and in the green. They have to be equal because the two angles are equal. Now from this, whatever you need, you write that ratio. So I'll write here what CD, which is this CD, which is side opposite to this angle. In a bigger triangle, in a green one is CD, in a yellow one is PQ. So we are writing green upon yellow. So CD upon PQ. Similarly, side opposite to 90. I need that. Yes, I need that because I need the ratio. So side opposite to 90 in a bigger triangle is what? Bigger triangle, green one is what? To complete this, I'm sure you are able to visualize the entire thing. Okay. If you complete this, side opposite to green one is PC, the bigger, which is this. So this is 90, side opposite to this is this, which is 3y plus y. That is equal to 4y. So that is equal to 4y. Upon side opposite to 90 in this yellow triangle, if you put this here in this yellow triangle, side opposite to 90 is what? As you can check it, it is this, which is 3y. Okay, 4y upon 3y. That's all. You got the ratio now. So this gets cancelled. No need to write the other sides. Okay, not required. You just find out what you need answer for. So the ratio here is 4:3. Okay, what are they asking you? What is the ratio of CDs to PQ? So if the answer was given 4:3, I would have marked that. But as you can check it, they had made the numerator 1 everywhere. So what will I do? Make the numerator as 1. So for that, if the ratio is 4:3 and I want to make this numerator as 1, what will I do? Divide both sides or divide the entire ratio by 4. If I divide the entire ratio by 4, what will this become? This will become 1. And 3 by 4 is 1 by 4 is 0.25 into 3, 0.75. Right? So 1 is to 0.75. Option number B is your answer to this question. So as you can check it, we just saw which triangles were similar and how we understood that what is given and what is asked. So from what is given, what can I get? And whatever I got, how can I apply this to get to the final answer of what is being asked to me? The simple thing, just prove that two angles are equal. Then you prove two triangles are similar. Then the ratio of their sides will be same. That's all I used. In the first case, I proved that this is equal to this. These two triangles are similar. So from that, I got the ratio of this. I knew I had to get this because then I'll be proving this bigger triangle is similar to this smaller triangle. Again, two angles are equal. So the ratio of their sides will be same. One of the ratio I already knew. So from that, I was able to find the other ratio quite easily. That's how you apply the concept of similarity to get to the answer to the question. So now we see the next problem on similarity. This problem came in the year 2004. So let's understand how do we apply the concept which we have just learned with respect to similarity of triangles. So a father and his son are waiting at the bus stop in the evening, and there is a lamppost behind them. The lamppost, the father and his son are standing on the same straight line. The father observes that the shadow of his head and his son's head are incident at the same point on the ground. If the height of the lamppost and the father and the son is this respectively, and the father is these many meters away from the post, then how far is the standing from his father? Okay, so very simple problem. Again, based on the concept of similarity, okay, because you will be finding that the triangles will become similar here. Okay, so let's make a diagram. You will understand this better. So three people are standing, the father and the son and the lamppost. The lamppost, the father and the son are on the straight line. So what is happening now? See, and the height of, as you can see, the height of the lamppost is this, the height of the father is this, and the height of the son is this, and they are standing in the one and the same line. And the shadow of the lamppost is falling on the father and the son, and it is being incident at the same point. There is only one way to make this triangle. So if I say this is the lamppost, which is of the height of 6 meter, and if I say this is the father who is of the height of 1.8 meter, then this would be your son who is of the height of 0.9 meter, and this is where their shadow would be falling, right? And if I just connect this by one line, so I say that there are right angle triangles that I can see it here, right? Or let's put it here. So let's say their shadow is falling at this place. That's how I start with my diagram. Right, now you can see there are many similar triangles that will be made here. So how is their shadow falling? Let me just change the color. Okay, their shadow is falling something like this here. Now if you just connect this in the right way, so this is the height of the father and the son, and that's how they are standing here, such that their shadow is falling there. So I make the diagram as it is being given here, and now let's just give the numbers to it. So this is 6, the height of the lamppost. This is 1.8. Okay, that is the height of father, and this is 0.9, that is the height of son. So I know everything, and as I understand this, see, even before I solve the problem, I understand a lot of things. This is a yellow triangle. Okay, let's not make this here. Let's see, this is a yellow triangle. If I cover this part, I'm talking about this triangle. Just this yellow would be similar to this green. Yes, this green is this big one, and this green would be similar to, let's say, this blue, which is this and then this. Okay, so as you understand, this three triangles would be similar because it's triangle inside a triangle, and understand that whenever you say a triangle inside a triangle, they have to be similar. That's quite logical. Okay, because one angle is 90, in all these three triangles, one angle would be 90 and the other angles would be something that is a common triangle, common angle. Okay, that's what you understand from this. So I say that this angle is 90, yes. This angle is 90, yes. This angle is 90, yes. So automatically you can see that these three triangles are becoming equal. One is this yellow one is this green one. So in green you consider the yellow as well, and one is this blue one. In the blue you consider both the yellow as well as the green. So if I complete blue, it will look something like, okay, how are they equal? Because one of the angle here is equal to 90 degree and the other angles are all common. This is a common to this is a common angle to yellow one, this is a common angle to green one, this is a common angle to blue one. Okay, that's how you see that they have to be similar now because two angles are equal. So third angle, which is this in this, which is this in this, and which is this in this will automatically become equal. Okay, see, that's how you apply this concept. And understand one more thing here. Whenever there is a triangle inside a triangle in a right angle triangle, they will be similar. So next time you don't have to think on this. You just need to know there is a right angle triangle. Inside that there is one more right angle triangle. They have to be similar. Now you know why. There is one big triangle. Inside that there are two other triangles. So all the three would be similar. Because two angles will always be equal. One is always 90. Other is always the common angle. They all become similar. Okay, that's what I understand. So I could have solved it quite fast, but then I wanted you to visualize this property. So next time onwards, when you see such problem, you should be able to connect. Now we know everything. Now just find out what is being given here and what is being asked. So the father is standing at a distance of 2.1 meter away from the post. So this distance is given to me as 2.1 meter. Then how far is the son standing from his father? Okay, that is my question. So they are asking me this: how far is the son standing from his father? Means this distance. Okay, because we know that this is sun, this is father, and this is the lamppost. So everything is clear, right? So let's just find it out now. So what will I do here first? I'll see which two triangles I'll start with so that I get to my answer, because I know what is being given and what is being asked. So which two triangles I'll start with? Let's start with them. Okay, 1.8 and 0.9. So I'm starting with yellow and green. I'm starting with this yellow. I'm starting with this green. And for green, you have to understand I'm talking about this. Okay, the entire green, not just the part that you can see in green. It's the entire green. So what will you say that in this yellow triangle? What could you say? This side 0.9. Or if I talk about green, let's start by green. So you can say 1.8. So I'll see this angle now here, which is opposite to this. Okay, so I know 1.8 upon 0.9 in this yellow and then green. This upon this is equals to, these two angles are equal, right? We already know this. So side opposite to this angle is what? X plus this. So I'm saying let this be equal to y. Okay, I need to find out x and y so that I can reach on to my answer. So you can say side opposite to this is nothing but x plus y. So x plus y upon side opposite to this, which is nothing but y. That's what I get it from this part. So this is 9 ones are 9, 2s are 18. So what do I get it from here? Okay, 2y is equals to x plus y. Okay, so from this you can get that x is equals to y. Okay, that is the first part that I get it from this equation. Now once I get this, I can think of the other triangles which are similar here. So I know this, which is x is equals to y. Okay, that is the first thing I know from this part. Let's write it here. We know this. So we thought of now what? Yellow and green. Okay, now it would be what? Green and blue. Okay, or you can say yellow and then blue. But then what do you need? You need x, right? So it will be better if we go for green and then blue. So I'm talking about this two triangles now. This one. The blue is, as you understand, it's the entire thing. Green one. Okay, this is 1.8. So what can you write in this two triangles? So you can say 6 upon 1.8. Okay, that is, I'm checking what? This angle. The side opposite to this angle in the bigger one, blue one is 6. The side opposite to this angle in The smaller one, that is the green one, is 1.8. So 6 upon 1.8 is equals to what? That will be equal to, now I'll check for this. Okay, hypotenuse is not at all required here, so don't worry about that. So side opposite to this is this entire thing, 2.1 plus x plus y. So I'll write it here, 2.1 plus x plus y. Okay, the entire thing is being divided by what? X plus y. Okay, that is what I get from this part. Now what do I know? I know that x is equals to y. Okay, that is something that I know from the first part only. So substitute it here then. So this becomes what? I need to find out x. Okay, so put y as x. So I'll say that this becomes, this is, first just convert this. This is 60 upon 18. So you can write this as 6 tens are 6, 3s are 18. 10 by 3 is equals to what? 2.1 plus y I substituted as x. So x plus x, this becomes 2x upon the entire thing is being divided by 2x. Now just solve this to reach on to your answer. Okay, so if you just multiply this, this becomes what? 10 into 2, 20x plus this is the entire thing. Let me write it here so that you can see it. So this becomes what? 10 into 2, that it becomes 20x. Okay, is equals to, this is 6.3 plus 6x. Okay, that is what you get from this part. Just cross multiply and reach on to the answer. Now what? 20 minus 6, that is equals to 14x. Okay, 14x is equals to 6.3. So what will I do now? X is equals to 63 upon 140. Now just solve this to reach on to your answer. Okay, obviously you will get something in 0 point, but what is the answer? So 7 2s are 14, 0, 7 9s are 63. Then what do you get this? This is 9 by 2 is 4.5, but then there is one more 0, so 0.45. Right? So option D is your answer to this question. So quite a simple question. Okay, it is just that you need to know which two triangles are similar. So all that you see, as soon as you see, this can be solved in a minute. Okay, in an exam you have to solve this in 45 seconds. So all that you will understand, these two are similar. So this angle, you know it. So 1.8 upon 0.9, that will be equal to x plus y upon x. So x becomes equal to y in this two. Then you check this one and then this one, blue and then green. So in this entire thing upon this entire thing, okay, that is equal to your 6 upon 1.8. And you already know that x is equals to y from this two. Okay, so as soon as you apply this, you will reach on to your final answer. So that's how you use the concept of similar triangles to reach on to the answer. And here we learned one more thing, just the way to see this. If there is a right angle triangle, inside a right angle triangle, they will be similar. Because one of the angle will be 90 and the other will be the common angle. Okay, so next time you don't even think to prove that they are similar. You know that they will be similar. Just apply the property and get to your answer.